In this video, we are going to solve this example number 2 of chapter 5, which is equilibrium of rigid bodies for 3D. As we see, we are given a pipe that has a fixed support at A as shown in the figure, right? And is subjected to 3 forces, 400 newtons, 500 newtons, and 600 newtons. The first step solving our problem is to see if we have a coordinate system, and we do. So if we mark our coordinate system just to make sure that we see it, X, Y, and Z. And then the second step will be do our free body diagram. So let me write here free body diagram. And I'm going to use the same drawing because this will be easy, but we have to understand that we have to isolate our system from the surroundings. So it's like I take the fixed support out of the pipe and I draw the pipe with the forces that fixed support produces. So I will draw, as we said, it restricted all degrees of freedom, so I will have a force in X. I'm going to call it AX. I'm going to have a force in C, is AC, and then I have a force in AY. And it restricted also all the rotations, therefore we have 3 moments. We have a moment in I, so let's call that MIX. Then we have a moment in Y. Let me draw them all positive. So a moment in Y, and then we have a moment in C, moment AC. Now that we have our free body diagram, let's take our equations of equilibrium, right? So the next step will be equations of equilibrium. Then, as you know, for 3D and rigid bodies, we have to have all forces as a vector equals to 0 and moment respect to a specific point equals to 0. And those lead to 6 equations of motion because it's Fx equals to 0, Fy equals to 0, Fc equals to 0, and then we can have either moment equals to 0, which will be moment Ax equals to 0. You write it in to make a difference between those here. I'm going to write it in small letters, and then AC equals to 0. As you know, taking moment respect to an axis, we can actually use any point of that axis. So eventually we could all write only mx, my, and mc. So let's take our equations of equilibrium. So let's add forces in x, and that will be equals to 0, right? And we have AX. What other forces we have? Minus 400 newtons equals to 0. Then add forces in Y. Then we have AY plus 500 newtons equals to 0. And forces in C equals 0. And then we have AC minus 600 newtons equals to 0. So those will be our first 3 equations, 1, 2, 3, and then we take moment. We can take moment respect to axis. So if we take a moment respect to axis, will be the axis X, axis Y, and axis Z. So we take the moment of respect to X. So we can use any point of X, and then we see which forces create moment respect to X. First of all, we have to put the moment that is applied right at the fixed support, and then we see which forces create moment. So 400 newtons is parallel to X, so it doesn't create any moment. 500 newtons is at a distance. The distance is 125, and it produces a negative moment. So we'll say minus 1.25 times 500, and then I have the 600s. The 600s, as you see, is respect to x-axis is this distance right here, will be this distance right here. which is 1 meter. So I'm going to, and the moment that it creates is also negative. So it's negative 1 times 600. And that's equals to 0. So this is my fourth equation. Then I have moment respect to axis y. Respect to axis y, 500 doesn't generate any moment because it is parallel to y. So I have the 400 and the distance from the axis is 0.75. So I will write again my moment in y minus 0.75 times 400. And the 600 is the distance is equals to this one right here now, 0.75. So I'm going to write here, and the moment is also negative. 600 equals to 0. So this is my fifth equation. And finally, I have the moment at C, and I have that moment AC. And which ones generate moment respect to C? The 400 crosses the axis. The 500 also crosses the axis. Then we have the force 600, but that one is parallel to C. So none of those forces produce moment respect to axis C. Therefore, the moment in C is equals to 0. So this is my sixth equation. So we have a system of 6 equations with 6 unknown. As you see, they are very easy to solve. So let me start solving them. Solve the equations so that the next step will be solve system of equations. And then we got from the first equation, so from 1 we can solve for ax equals 400. From 2 we have that ay is equals to negative 500. From 3 we got that AC is equals to 600. And then from 4 we have that moment at AX is equals to 600 newtons meters. From 5 we got that MAY is equals to 750 newton meter. And from 6 we already have that the moment at C is equals to 0. So we were able to solve our system of equations of 6 equations with 6 unknowns. Very easy equations to solve, and these are the results for this problem.